September 13th, the area model. Before we go too deep here, let's look at the challenge problem from the end of yesterday's practice. Simplify by distributing the quantity 2x plus 1 times the quantity 3x minus 2. If I was going to use distribution, I would multiply each term from the first expression by each term in the second expression. 2x times 3x, 2x times negative 2. However, I would also have to multiply the plus 1 by 3x and the plus 1 by negative 2. So 2 times 3x, 2x times 3x, is going to give me a 6 times x times x. A common convention when we're multiplying two x's like this is to use a degree of 2, or to simply rewrite that as x squared. Next up, I had 2x times a negative 2. This gives me a negative 4x. I follow this with a 1 times a 3x, which is 3x. And lastly, a 1 times a negative 2, or a negative 2. I can combine some like terms here, negative 4 and 3. And this gives me a negative x. My final answer, 6x squared minus x minus 2. Let's review how to multiply together two variables. If I have x multiplied by x, this is going to give me x squared. They are equivalent. If I take x squared and I multiply that by another x, I'm going to get x cubed. The trick is we are adding the exponents, and an x by itself actually has an exponent of 1. So x times x, we add together 1 plus 1, and our new exponent becomes 2. X squared times x, we add together 2 plus 1, and our new exponent becomes 3. This works with any number for an exponent. If I have x to the third multiplied by x to the 7th, how would I figure out my new exponent? I add 3 plus 7, and I get x to the 10th. As you can see, basic distributing is a mess here. The key to making this easier comes from one fact. Everything in the first term has to be multiplied by everything in the second term. As long as this is the case, we can multiply through a technique called the area model, or as I call it, hashtag multiplication, or the box method. Let's use the example above, the quantity 2x plus 1 times the quantity 3x minus 2. I start with a box, as this is called the box method after all, and I'm going to take that first expression and break it into its component parts. 2x and a positive 1, I will split 1 into each row. My other expression, 3x minus 2, I will do the same thing along the top. The technique I use here is to multiply each row by the column. So, this first one gives me 2x multiplied by 3x, which is 6x squared. I do the same thing, 1 times 3x, which gives me a 3x, 2x times a negative 2, negative 4x, and lastly, the positive 1 and the negative 2 multiplied together give me a negative 2. I combine like terms, 6x squared minus x minus 2. Same answer, different technique. When you're multiplying binomials like these two, it can be a matter of preference. As we start to expand into multiplying trinomials, or larger polynomials even, the area model becomes far more organized and you make fewer mistakes. Let's try another one. I'm going to draw my box, 2 rows and 2 columns. Negative 4x I'll put here on the left, minus 2, both of these coming from this expression. I'm going to write 2x and a positive 5 for my columns. I multiply row by column, and I get negative 8x squared. I multiply row by column, and I get negative 4x. Row by column, negative 20x. And row by column to get negative 10. You might notice my only like terms here are along this diagonal, negative 4x and negative 20x. When I combine like terms, I can rewrite the equation as negative 8x squared minus 24x minus 10. One final example. This box is going to look a little bit different because I'm multiplying the quantity 2x squared minus 3x plus 4, which has, count them, 1, 2, 3 different terms. So when I draw my box, I'm going to draw 2 rows and 3 columns. I will take the terms from my trinomial, which is 2x squared minus 3x plus 4, and I will put them along the top of the box. 2x squared minus 3x and 4. I can put a plus 4 if I want, or I can leave it. It's already implied to be positive if there's not a negative. The other side I write as 5x and 6. To fill in these boxes, I'm going to multiply row by column. So if we follow along, 5x multiplied by 2x squared. This gives us 10x cubed. 6 times 2x squared gives us 12x squared. 5x by negative 3x, negative 15x squared. 6 multiplied by negative 3x gives us negative 18x. 5x times a positive 4 gives us 20x. And lastly, 6 times 4 gives us 24. We combine our like terms, which are going to be again along these diagonals. And our final answer is 10x cubed minus 3x squared plus 2x plus 24.